Hello everyone, this is Sir Elmer once again, and today we'll be talking about the factoring of the perfect square trinomials. So what are perfect square trinomials? The square of a binomial is a trinomial. Such trinomials are called perfect square trinomials. So we have here some examples: x plus 2 quantity square, x plus 3 quantity square, 2x plus 3 quantity square, and x plus y quantity square. So these are all binomials. They are being raised to the power of 2. So if we simplify such binomials, then the result is a trinomial, and specifically, they are the so-called perfect square trinomials. For x plus 2 quantity square, the result will be x squared plus 4x plus 4. For x plus 3 quantity square, we have x squared plus 6x plus 9. For 2x plus 3 quantity square, we have 4x squared plus 12x plus 9. And lastly, for x plus y quantity square, we have x squared plus 2xy plus y squared. These products are what we call the perfect square trinomials. They are the result of the squaring of a binomial. Now, how do we know if a trinomial is a perfect square trinomial? We have three requirements to determine if a trinomial is a perfect square trinomial or not. Number one, two of the terms must be perfect squares. Now for our analysis, we shall be using the trinomial 4x squared plus 20x plus 25. So for the first requirement, two of its terms must be perfect squares. By analyzing, we can see that 4x squared is a perfect square and 25 is also a perfect square. So we will have a check mark for the first requirement. Second requirement, there must be no minus sign before the perfect squares. Now earlier, we have determined that 4x squared and 25 are both perfect squares inside this trinomial. Now we will look if their sign is positive. So for 25, obviously it's positive because of the presence of the plus sign in front of it. Now for the first term, 4x squared, since no sign is visible, that means that it is positive as well. So for number 2, we have also a check mark. Third requirement, if we multiply the square root of the first term and the square root of the last term, the resulting product or its additive inverse must be equal to the middle term of the trinomial. The first term of this trinomial is 4x squared. Getting its square root, we will have 2x. Now the last term, which is 25, its square root is 5. Now what we will do is to multiply these two square roots and then double them or multiply them by 2. Doing that, 5 times 2x, we have 10x times 2 equals 20x. Now we will compare this resulting product to the middle term, and if they are the same, then that means that we have also a check mark for the third requirement. So as you can see, we have 3 check marks for the 3 requirements in determining if a trinomial is a perfect square trinomial. Now what does that mean for the trinomial that we are analyzing? That means that this trinomial is an example of a perfect square trinomial. So that is how we determine if a trinomial is a perfect square trinomial or not. Now how do we factor a perfect square trinomial? Now in discussing the steps to be followed in factoring a perfect square trinomial, we shall be using this example, x squared plus 10x plus 25 as our trinomial. Now please bear in mind that from here on out, all examples of the trinomials that we will be using are all perfect square trinomials. But before applying the steps that I will be discussing in here, make sure that the trinomial that you are going to factor are perfect square trinomial by applying the 3 requirements that we have discussed earlier. So the first step is to prepare our 2 parentheses such as this. Next, get the square root of the first term. Then write in each of the 2 parentheses as the first terms of the 2 factors. So the first term is x squared, its square root is x, and we shall write x in each of the 2 parentheses such as this. After that, affix 2 similar signs after the first terms of the 2 factors. These similar signs will depend on the sign of the middle term. The sign of the middle term is positive, hence we shall affix 2 similar signs in each of the 2 parentheses, 2 plus signs. Get the square root of the last term of the given trinomial, then write in each of the 2 parentheses as the last terms of the 2 factors. 25. This square root is 5, and we shall write in each of the 2 parentheses, such as this. And that is the last step in factoring a perfect square trinomial. After doing that, we have now obtained the factored form of the given trinomial. So those are the simple steps to follow in factoring a perfect square trinomial. Now let us try another example. 16x squared minus 72x plus 81. Once again, our two parentheses. Get the square root of the first term, 16x squared. Square root is 4x. Then we will write 4x in each of the two parentheses as the first terms of the two factors. Affix two similar signs after the first terms of the two factors. These similar signs will depend on the sign of the middle term. This time, the sign in the middle is a negative sign or minus sign. Hence, we shall write two minus signs in each of the two parentheses. For the last step, we will get the square root of 81, which is 9, and we will write it in each of the two parentheses, such as this. And that is the last step in getting the factored form of a perfect square trinomial. So for this example, we have now obtained its factored form, 4x minus 9 times the quantity of 4x minus 9. For our third example, we have 25m squared plus 20mn plus 4n squared. Once again, our two parentheses. Then get the square root of 25m squared, our first term, that is equal to 5m, and write in each of the two parentheses. Then affix two similar signs depending on the sign of the middle term. So the two signs are two positive signs since the middle term has a plus sign. And for the last step, get the square root of 4n squared, that is 2n, then write in each of the two parentheses. We have 2n. So the factored form of the given trinomial is 5m plus 2n times 5m plus 2n. So thank you for watching. That is the end of our video. I hope that you have learned something once more. Once again, this is your Sir Elmer, and I'll see you in my next video. Peace.